Hi everyone, welcome back to my channel. You are watching Education to All. So this is Vinod Kumar, Math Teacher. Today I will discuss the real numbers, topic 1, exercise 1.1. Question number 1, express each number as a product of its prime factors. In that Roman number 1, so we try to solve the prime factors for the Roman number 1, 140. In 142 table is cancelled, 2 table in 14 7 times and it is 0, so 70 times. Again 2 table 35 times, 5 table 7 times. Therefore the prime factors for 140 is 2 into 2 into 5 into 7, and we can write as 2 square into 5 into 7. Similarly, Roman number 2. So Roman number 2 is 156. Last number is 6. So unit is an even number. So it is cancelled by 2. 1 it is not. So in 15 7 times. And 1 carries 16. In 16 8 times. Again unit digit is even number. Again 2 table. 2 table. 3 times 6. 1 carries 18 means 9. 3 table is cancelled now, so 1 time and 3 times 13, so 13 is a prime number, we can stop it. In 156 prime factors are 2 into 2 into 3 into 13, so this we can further write as 2 power 1 2 power 1 not 2 power 2, it will be into 3 into 13. Got it? Now Roman number 3, 3825. If unit digit is 5, 5 digit is cancel exactly. So prime number 5 when you divide with the given number. In 38 it is cancel in 7 times 35, 3 pending, 32. 32 means 6 times 30, 2 pending, so 5 times 25. Again unit digit is 5, definitely 5 table, 1 time, 2 pending, so 26 means 5 times, and 1 pending, 15 means 3 times. Then again you observe that addition of these digits is will be divisible by 3. 1 plus 5 is 6, 6 plus 3 is 9, so divisible by 3. 5 threes are 15 and 1 carries. Again it is divisible by 3. So how many times? 1 time, 2 pending, 7 times 21. So therefore the prime factorization for 3825 will be, so 5 into 5, 5 square, into 3 into 3, 3 square, into 17. So we'll try to solve the same way Roman number 4 and Roman number 5. Number 4, so which is 5005. What are the prime numbers can be cancelled in it? So I'll take 5 table is prime number in it. So one time in these two zeros, 0 only. Here it is one more time. In 1001, 11 table is cancelled. 11 table in 100, 9 times. 1 pending, so 11, one more time. In 91, so 13 table is cancelled 7 times. So the prime factorization for 5005 is 5 into 11 into 13 into 7. So I'll write in a proper order. 5 into 7 into 11 into 13. So this is the prime factorization for 5005. And one more, Roman number 5. So Roman number 5 is given 7429. What are the prime factors will cancel in it? So I'll take 17 table in it. So 17 table in 74 approximately 4 times. 4 times is 68. So what is pending in 74 subtracted to 68? Now you will get it as 6, and it is one more to 62. Approximately 17 table in 62 cancel 3 times. So 17 3s are 51. So subtract 51 from it. So 3 times 51 is subtracted here. You will get 1 and 1. So at last number is 9. In 119, 17 table cancel in exactly 7 times. So next one, what tables are cancelled in it? So I can take that 19 table. So 9 hint to get exact answer. See, it is 9, but we should get the unit digit is 7. How can I get? 3 9 ones is 9, 9 twos are 18, so 9 threes are 27. So we can cross check this 3 table is multiplied. 3 into 9 27, 2 outside, and 3 ones are 3, 3 plus 2 is 5, 57. But one more requirement is second digit is 3. How 5 will be becomes 3? So when you add 8, it will becomes 13, so ending with 3. I'll take it as 2 nines are 18, 1 carries, 2 ones are 2, 2 plus 1 is 3. So add it 7, 13, 1, 437. So absolutely 23 times. And here you should aware of it. 17 is a prime number, 19 is a prime number, 23 is also prime number. We can stop it. So therefore the prime factorization for 7429 will be 17 into 19 into 20 then. We'll continue for the second question as well. The second question is given. Find the LCM of and HCF of the following pair of integers and verify that LCM into HCF is equal to product of the two numbers. First we try to find the LCM and HCF by using prime factorization. So the first Roman number 1, I'm taking 26 and 91. First 26, what are the prime numbers are there? I'll take the 26 as 2 table in 13 tables. So 2 table and 13 table is prime numbers definitely. So that will be the prime factorization simply. And next numbers are 91. So 91, what are the tables will be cancelling it. So in 91, 7 table cancel 13 times. Okay, both are prime factors are written. So the task is to find LCM first. So LCM I am finding first. So LCM is abbreviated as least common multiple. So whenever you are taking the prime factorization LCM, we should take the all possible values. So 2 is there, 2 is not there. Even though we have to consider 2 is multiplied by 13 is there in repetition, so 113 will be taken. And next, this 13 is over, 2 is also over. What is extra pending? 7 alone. So 7 also will be included for that. So therefore you multiply all these three numbers. So 2 into 13, 26 into 7. So therefore answer is 182. So you get answer is 182. I'll say that the LCM between these two numbers is 182. Similarly, we try to find HCF also. HCF finding is quite simple when compared to the LCM. Whenever any two or three numbers comparing HCF, we have to take only the common prime numbers are there. What are the numbers are prime or not a prime? We have to take that only common numbers. Here 13 is common with this is also 13, and the remaining numbers no need to take. Then highest common factor HCF, and also called GCD. GCD means greatest common divisor. So means which dividing greatestly. So 13 table is dividing greatestly. Only 13 is common na. So I can take a HCF is 13. And we have to verify that LCM into HCF is equal to product of the numbers also. So I'll take that numbers as well. First, product of the numbers. Product is equal to, what is the product of numbers? 26 into 91. And you multiply 26 into 91, you get 6 ones are 6, 6 1 2s are 2, and 9 6 are 54. So 5 is outside, and 2 into 9 18, 18 plus 5 is 23. So add all together 6, and it is also 6, 2366. So the number is 2366. And product of LCM on HCF also. So we'll find LCM into HCF. So what it the answer will be? LCM is 182, we get it, and HCF is 13. So multiply these both also, you get what? 2 3s are 6 and 3 8s are 24, 2 outside, 3 ones are 3, 3 plus 2 is 5. Next, 2 ones are 2, 2 1 eights are 8, and 1 ones are 1. So add all together, here it is 6. This both addition is also 6, and this both is 13, 1 carries and 2. So therefore you can cross check. It is very simple to understand. LCM is also, you get LCM into HCF is also, we get it as 2366. Therefore we can cross check the LCM into HCF is equal to product of two numbers. I hope you get understand, and we'll try to check the second Roman number 2 in it. 510, I'll write the prime factorization. 51 into 10, so this can be further written as 3 into 17 into 5 into 2. So I written 51 as 3 into 17, 10 as 5 into 2. So this is a prime factorization. I'll write in ascending order 2 into 3 into 5 into 17. Similarly 92. What are the prime factorization for 92? So in 92, what are the prime numbers are there? 92, 2 table is cancelled 46 times, again 2 table in 23 times. So therefore we can say that 2 square into 23 will be the prime factorization for 92. Got it? Then similarly we try to find the LCM for the given numbers. So LCM, how to take LCM? First we have to consider the common numbers. 2 here, 2 square here. So I can say that 2 square is common, and 3 no 3, so we have to consider even though, and 5 no 5, that is also must be multiplied. 17 no 17, so that's also should be multiplied, and 23 is pending, so 23 is also we have to consider. It's very simple to understand. The common elements are what there are, common numbers are what there, that exponent which is greater, that we have to consider. For example, we have 2 square in 92, for example I'm taking, and in 32 we have 2 power 5. So what we have to consider is LCM now. In 2 to power 2 and 2 power 5, 2 power 5 will becomes the LCM. Got it? Similarly try to find the HCF. When you are taking HCF, we have to consider the common element less exponent, smallest exponent. So similarly I'm finding HCF for the given numbers. In HCF you observe this is 2 and it is 2 square, so 2 alone should be taken, and 3, so no 3, 5 no 5, 17 no 17, this 23 no 23. So that's all we can say, only 2 is the HCF for that. What is the main difference between considering LCM and HCF? In HCF only common and lowest. In LCM, which having common or not, we take the highest common. If it is having any common, highest exponent is taken, and the remaining numbers having common also not also we have to take as a LCM consideration. So now I multiply all these together, the LCM will get it as, you check it the calculations. So when you multiply all these together, we'll get 1460 you get, and the HCF is 2. Now we'll try to find the product of numbers and as well as LCM into HCF. First I'll find the product of numbers. Which is 510 into 92. 2 into 0 is 0, 2 into 1 is 2, 2 into 5 is 10, and 9 into 0 is 0, 9 ones are 9, 9 fives are 45. So add vertically all these together, it is 0, 2, 9, 6, 4. So 46,920 will be the product of these both numbers. Similarly, product of LCM into HCF. So LCM into HCF. So what is LCM? We got it 23,460, and HCF is 2 number. And we simplify these both values as, so 2 into 0 is 0, 2 6 are 12, 1 carries, 2 4s are 8, 9, so 2 3s are 6, 2 2s are 4. So observe that answer in product of LCM and HCF and the product of numbers is absolutely same answers we got it. 46,920, 46,920. So what is the conclusion we can write for this question? Therefore, the product of numbers is equal to LCM of the two numbers into HCF of the that particular two numbers. Got it? And similarly, we try to solve the third Roman also. 336. What are the prime factors for it? So 3 table is cancelled. 3 table in it cancel in 112. Again 3 table is cancelled. No, 2 table is cancelled. 2 table cancel in 5 times 10 and 6 times 12. So in 56, what are the prime factors we have? Again 3 table is cancelled. 2, 3 into 2 into, so 2 table is cancelled. How many times? 2 table, 2 times 4 and 16, 28. And in 28, 3 into 2 into 2, 4 sevens are 28, so I can write 2 into 2 into 7. Now the prime factors for 336 are 2 are repeated 4 times now, so 2 power 4 into 3 into 7. So this is the prime factorization for 336. Similarly, we write for the 54 also. So 54, what are the prime factors we have? In 54, 2 table is cancelled 2 times in 5 and 14. So 27 times. 27 means very easily you can write that is 3 cube. So it is 54 prime factors. Now we have to balance the both exponents to get the LCM and HCF based on the given exponents. So I am finding LCM between the both numbers. So LCM is, we did 3 questions, we did 2 questions early. So the same way, first common numbers 2 and 2. So exponent which is having highest, this is having highest. So I can take it as 2 power 4 into 3 power 3 only 3. So which can be 3 power 3 will be. Next 7, no 7. So 7 is also can be considered. All these if you multiply, you will get 3024. Check it your calculations and do it. Now similarly find the HCF for this both. HCF is equal to 2 power 4 2, only the smallest exponent. 3 3 power 3, only 3 will be. 7 is there, no 7 is there, so we can stop the HCF and we can take the product of these both, we get 6. Now we have to cross check the product of numbers as well as product of LCM into HCF. First, product of numbers. Product of numbers. So product of numbers are 3036 into 54. So multiply manually. 6 fours are 24. So I'll write 4 here and 2 outside. 4 threes are 12. 12 plus 2 is 14. 1 outside, and 3 fours are 12. 12 plus 1 is 13. Now 5 6 are 30. 3 outside. 3 5s are 15. 15 plus 3 is 18. 1 outside, and 3 5s are 15. 15 plus 1 is 16. Add vertically all the numbers like 4 4, and here it is 11 and 1. So this addition is 8 and 1. So answer is, you get it as product of numbers 18,144. Similarly, try to find the LCM into HCF as well. So LCM into HCF. So check it, what is the LCM? We got it. So 3024 into HCF is 6. So now multiply all these both numbers. 6 fours are 24, 2 outside, 6 twos are 12, 12 plus 2 is 14, 1 carries, and it is 6 into 0 is 0, plus 1 is 1, and 3 into 6, 18. So cross check the both answers. In the first product we got same 18,144, so 18,144. Therefore, we can say that for this question also, product of numbers is equal to LCM of that particular numbers into HCF of the numbers. I hope you understand. If you understand, please like the channel and support my channel as well and share to your friends also. Now we try to solve the next question, question number 3. Now question number 3. Find the LCM and HCF of the following integers by applying the prime factorization method. LCM and HCF we should be find by using the LCM and HCF. So Roman number 1 is taken, 12, 15, 21. Three numbers are given. I'll take the first number 12. 12 I taken prime numbers as 4 into 3. So 4 is not a prime number, so I'll write it as 2 square into 3. For 12 it is. Similarly 15. 15 is very simple number to write as prime product. 5 3s are 15. Next 21. So 21 is 3 7s are 21. So it is very simple to get cross multiply. Now I'll apply LCM first and then we go for HCF also. So LCM is equal to, compare all the exponents. 2 square, no 2 square, no 2. So definitely 2 square we have to consider in LCM. 3, 3, 3. So that is also included. Next 5 is there. So 5 is also included and 7. 7 is also included in it. Then all multiply now. What you get? 2 square is 4 into 3 into 5 into 7. So 3 4s are 12. 12 into 3 5s are 5 3 7s are 35. So when you multiply these both numbers, you get it as 420. Similarly, try to find the HCF for the numbers. The HCF of these three numbers are 2 square, no 2, no 2. So 2 is not considered in it. So 2 is eliminated. 2 is not considered. 3, 3, 3. Only 1 3 will be. 1 5, no 5, no 5. Can I consider 5? Absolutely not. Next 7, no 7, no 7. So 7 is also not be considered. So therefore HCF of these three numbers is 3 and LCM is 420. Similarly, we try to solve the second Roman number 2 in the question number 3. Factors for 17. So 17 even a prime number, so no need of checking it. So 23, 23 is also prime number. Next 29, 29 is also a prime number. Then how to take LCM? So where LCM is equal to 17 should be considered, no 17, no 17. 17 also will be included. Next 23, no 23, no 23. So even 23 can be included for LCM. 29, no 29, no 29. Even 29 can be considered in it. Then multiply all these three numbers like 17 into 23 into 29. You get 11,339. Cross check your calculations. Now try to find HCF of these three numbers. HCF 17 is there, no 17, no 17. Can I consider 17? Absolutely not. 23, no 23, no 23. Can I consider 73? Absolutely not. 29, no 29, no 29 in product. So 29 also not. Then the HCF of these three numbers. So HCF is commonly multiplied by 1, commonly multiplied by 1. Here also 1. So I can say that 1. Why it is HCF is 1? Na? There is no common factors between any two numbers or three numbers or any numbers. HCF will becomes 1. We can also say that there is no common factor except 1. It is called co-primes. So 17 and 23 is a co-primes, and 23 and 29 is also co-primes, and 29 and 17 is also co-primes. So remember, for co-primes HCF is always 1. Got it? Remember, this hint is very important condition. For co-primes HCF is equal to 1. Now Roman number 3 we have to start. Roman number 3, 8. First number is 8. 8 I can write it as 2 cube. 9 I can write it as 3 square, and 25 I can write it as 5 square. First try to find LCM. So LCM is equal to what? 2 cube, no 2, no 2. So directly 2 cube will be included in LCM. 3 square, no 3 square or no 3, and it is also no 3. Can I include it? Definitely 3 square. 5 square, no 5, no 5. Can I include 5? Means 5 square, yes, absolutely should be included. Then answer for LCM is 2 cube 8, 3 square 9, 5 square 25. So then all you multiply these three numbers, what you get? And we get it as 1800 or as 1800 we can say. Similarly, try to find HCF for these numbers. I hope you can answer immediately. 2 cube, no 2. In this also no 2. So 2 can be included? Never. 3 square, no 3 square or no 3. Here also no 3. 5 square, no 5, no 5. So what is that? Here no common factor between these three numbers. So I can say HCF is 1. Similar to the previous topic, you can remind once again. For co-primes, HCF is 1. What is meant by co-primes? There is no common factor between any two numbers. We can conclude that numbers are co-primes. So can I say that 9, 8 and 25 is a co-primes? Definitely. So therefore HCF is equal to 1 for these three numbers. Next question number 5. It is given that HCF of 306 and 657 is 9. Find LCM of the 306 and 657. How to do this question? We have a relation between HCF and LCM. So what is the relation? LCM into HCF of two numbers is always product of two numbers. Product of two numbers. So apply the same condition for the given numbers. What is LCM is known. We don't know LCM, but we know HCF, that is given 9 in the data. So I'll take LCM as LCM only into HCF is equal to 9. That will be product of two numbers. What are the two numbers given? 306 and 657. 306 into 657. Instead of multiplication, I can divide this 9 table in 306. How many times? It will be cancelled. So 9 table in 30. So 2 times 80, 3 times 27, 3 times 27, and 3 pending 36 4 times. So therefore 34 into 657, and what is the multiplication you use? So you will get it as 22,338 will be the LCM. So therefore LCM will be 22,338. 5. Check whether 6 power n can be end with digit 0 for any natural number of n. So this question can be do in cross checking the prime factors of 6 in it, and we can justify the answer. If I take 10, 10 power 1 end with 10 is 0, and 10 square, so end with 100 means end with 0. 10 cube is also end with 0 only, 1000, so it is always end with 0. Then what is the rule you should identify? The rule is 10 power any number end with 0. So in that 10, what are the prime factors we have? 2 and 5. If any number having must 2 and 5 as a prime product, definitely that number is end with 0. So can I say 6 power n can end with 0? So we'll conclude it. First, we have tried the reason. If any number end with 0, it should have 5 as its prime product. In other words, we can say the number must divisible by by what number? 10. Okay, and we cross check whether 6 power n will have the both conditions or not. What are the prime factors of 6 power n? So 6 power n, so 6, 2 and 3 as the prime factors power n. Here we can easily cross check, 2 is there but 5 is not there. I can conclude it now. So in prime factors of 6 does not contain 5, so it never end with, does not end with digit 0. So therefore our answer is 6 power n never with 0. Got it? Explain why 17 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Before going to this explanation, you should aware what is meant by composite number. I'll write the definition, you please observe. Composite: any number having minimum 3 factors. If any number having minimum 3 factors, it is a composite number. What is an examples? You can see the 4. 4, how many factors having? 1 is a factor, 2 is a factor, and 4 is also a factor. So it's including the 1, 2, 4. 4 is a number now. That is called composite number. So we can also say the least composite number is 4. So coming to the explanation of this sixth question, given as 7 into 11 into 13 plus 13. Can you take anything common? Definitely 13, right? So 13 is taken out. What is pending in it? So 7 into 11. This is 13 is taken out. So plus this 13 is also taken out now. 1 pending. Then this can be written as 13 into 7 into 11 is 77 plus 1. Therefore 13 into this both addition is 78. Can I say 1 is the common factor for any number? So definitely. Now observe this given question having how many factor? Minimum 13 is a factor, 78 is also a factor, 1 is a factor. So it looking that it having minimum 3 factors. So therefore the given number is, it is what? Composite number. Got it? Similarly, we try the second question as well. So what is the second question is given? 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5, and which can be taken. 5 table is common na? You can see very carefully 5 is common in both that. So I'll take in that 5 is outside. What is pending in it? 7 into 6 into 4 into 3 into 2 into 1 and plus 1. So now you multiply these all numbers, you get it as 1008 and plus 1, then it will become 5 into 1009, and also every number is having 1 is a common factor. Now you check it how many factors it having. 5 is there, 1009 and 1. Now can I say is it a composite number? Definitely yes. Therefore it is a composite number. Got it? I hope you understand. Now last question, seventh one. There is a circular path around the sports field. Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes to the same. Suppose they both start at the same point at the same time and go in the same direction. After how many minutes they meet again in a starting point? It's a given question. This is a circular path. So path is a circular, no? So it is taken a circular path. Let's imagine Sonia starts at this location and she is starting running this direction. And after some time, one more boy, who is named that Ravi. Ravi is also starts at this location and starting in the same direction. She take that some rotations, they will meet again in the original place in the starting position after how many minutes. So this situation can be find answer can be find by using of LCM. So this is least common multiple. So that will be taken by LCM now. So what is LCM for 18 and 12? We have to cross it. Now 18, what are the prime factors? 2 into 9, 9 means 3 into 3. So I can say that 2 into 3 square. So 12, what are the prime factors of 12? 2 into 6. So 2 into 3, so I'll write it as 2 square into 3. So now I'll try to find LCM. So LCM is equal to 2 is there, 2 square, which can be considered 2 power 2. Next, 3 square, 3. What we can be considered 3 square. So therefore, 2 square is 4 and 3 square is 9. 4 into 9 is 36. So LCM is 36 in 10 minutes now. So I can say that. Therefore, the given condition is what? After how many minutes they will meet again at the starting point. So we can conclude that after 36 minutes they will meet again in the starting point. Got it? I hope you like my explanation. If you like, please subscribe and share to your friends. Thank you. Have a nice day.